morning, everybody. I'm a PhD student Ana Carlos. My prof tutor is Beneventano. I will present you quality graph and query processing. So the last year we started our research activity about query optimization, and we obtained some previous results. And during this year we try to extend our activity to including some aspect of data quality. So MOMIS is the information integration system where a global query posed by user is rewriting over local source. Each local source provides a partial result which fused and reconciliated into a single unified answer. So, to rewrite a global query, we need to have a mapping table. We give a set of correspondences between global schema and local source. During this process, we have used Untejon to fuse the partial results from the partial results coming from different local sources to unify it and present to the user. During this process, we need to define some resolution function, example data conversion function, to convert some data into a global format. We have joint condition where it's defined on some attributes. We consider an ED attribute. Finally, we have to define resolution example for resolution function AVG, where we try to calculate the average value from all value coming from different local sources. So all the process to obtain the unified answer, we define Full-Join image. Our work consists to how to answer the query expresses on the global schema. We remember that MOMIS have the graph approach. We consisting to define the global view over the local sources. And we, in the MOMIS, we can define two types of attributes. Homogeneous attributes, where it is possible to push down a constraint on the local level. And we have a non-homogeneous attribute, where we can solve the constraint at the global level. These two definition of attributes is very important for us because these two definitions we involve in our Full-Join optimization. So I will give you some example for previous work we done the last year. See, here we have some query. Some query, that is the general form we can rewrite query and solve and to obtain the final result. What we are doing to optimize this process to obtain the final results. We can, in our study, we consider a query in conjunctive form, where in the clause where a constraint is the form like P1 and P2. So we can see some optimization. We can see a constraint is pushed down to source 1, and we can optimize to replace the Full-Join on other operator will not require more cost. So if we can add another constraint, we can obtain other optimization with the another operator which is very fast to obtain the final result. So that I finished to present is the previous work we can do the last year. So during this year we can try to extend our work to include some aspect of data quality. We individuate 4 dimensions we returned more important in literature: syntax accuracy, completeness, consistency, and coherency. So this 4 data quality dimension, we decide to normalize their value in the interval 0, 1. In this definition, and where we try to obtain this value is defined in the deliverable of the project of NetB for Business. So to include data quality, we extend our mapping table for extended mapping table, where we represent each local attribute with its quality dimension. So in the other case, we can have some quality data quality dimension have value null because we don't know what is valued. And the next, we try to extend our query. So we include the using clause. We include the using clause to specify some constraint on the data quality dimension. So we take inspiration from Mbikeu for his article. So we can give the intuitive semantic of our query. So we can see the global view, where we obtain by Full-Join image computation. But then we have to apply a resolution function for global attribute. In general, is the attribute where the user can see the data. And finally, we have the global constraint. So we have to include the restrictive clause to consider that data quality we have null value, because the code tree logic value we have may be crude and phase. In general, maybe we consider phase on the comparison. So to take into account the possibility that some data quality can have the value null, we can include in our query the keyword restrictive. That finally, with this work, we obtain some result, where is the optimization, projection reduction, consists to reduce the selected list on some local source. We have to obtain predicate push down. We give us the possibility to filter our data directly to local source. And we have the Full-Join simplification. So we can give some intuitive example. That is the simple query we have, and so we have to include using clause. We have the different results. So I'm presenting you how we can obtain this result. That is the simple process to obtain the result with our first simple query. So when we include our using clause, the process is slightly different, because we can reduce the select list of the local source L1. And the complete example we can present now. So we include using. You have to obtain this data where some values from LUD are not considered. We can push down the constraint, the global constraint on the local source LED. And finally, we obtain some simplification of the full join. We can eliminate the application of result constraint, and we can obtain the final result. So we present the procedure to rewriting the extended global algorithm we presented. Okay. Thank you. I'm finished.
That in the next year you are implementing these techniques in the system, because it seems to me that, okay, theory is good, but we have to apply theory to real system. What have to tell me?
But now we just finished the first phase of the work. We can consider now the possibility to optimize query when we include the restrictive clause, and we have to respond some small question, but we think for the next 3 months we can have some consolidation of the final research of this area. That is yes. Okay, thank you.